Hello, everybody, and welcome to yet another Zoom recording interview. This time, a PhD graduate student from Purdue University, Brandon, and I don't even know how to pronounce your last name. We're just meeting. So, Brandon, what is your last name, and what's the weather like today in West Lafayette, Indiana?
My last name is Keough, and
Keough.
the weather's great. We're having a stretch of about 65 and sunny and perfect fall weather.
Ah, I missed that. I missed that crisp autumnal scene in the Midwest. So great, good for you. Let's get right into this, Brandon, and maybe I can talk directly to the viewers for just a second. Viewers, I'm still ramping up piece by piece, interview by interview for the upcoming Alaska A to Z live stream series, which will start on November 6th. And I think I'm only doing a few more of these before I think I have the kernels and the little nuggets that I'm looking for to get myself going in a certain direction. Brandon is the latest of a number of interviews. So there's plenty that Brandon can share with us. I'm coming as a rookie thinking about Alaska. So let's start, Brandon, with we're going to be up together in Alaska next summer in June.
Mhm.
You and Ken Ridgway and Mike Eddy, all from Purdue University, and myself. But this is not your first field season in Alaska. Can you fill us in on how many seasons you've been up there and who have you been working with during those seasons?
Yeah, I've done 5 summers in Alaska at this point. It goes back
Nice.
to starting around 2018. That was the year I was entering my master's at Purdue, which I did from 2018 to 2020. At that time, we were actually working with a pretty large group. There were some students that have since graduated. Wei Allen was doing her PhD. Cooper Fasula was doing a master's, and then we were working with collaborators like Paul Fitzgerald at Syracuse, Jeff Benowitz. And we were mostly in the Alaska Range that summer. We started off in the Eastern Alaska Range, and then I did some work which was leading into my master's work in the Central Alaska Range in Denali National Park. And then the next 2 summers, 2019 and a little bit more in 2020, I worked entirely in Denali National Park. I
Hmm.
was doing some tectonics research and sedimentary basin analysis. And we also did some work with the Park Service itself and with the USGS. We were doing some mapping that related to geohazards along the park road, which is real pertinent now. They have some issues that have shut down over half the park road, and we've had some cool interactions over the years with the Park Service on
Okay.
that.
Nice. So far, I'm hearing that you were a master's student up there, and were you working under the tutelage of Ken Ridgway?
Yeah, I was working with Ken Ridgway at the time, and Mike Eddy was just starting at Purdue, I think in 2019.
Yeah.
So we interacted a bit then, but it wasn't until I came back to Purdue actually after working for a while that I started working with Mike and Ken as a co-advised student.
Very good. So, what was the title of that master's project? And was it, when I think of Ken Ridgway, I think of sedimentary basins. So, was it a sedimentary type thesis, master's thesis?
Yeah, it was kind of a combination, and I think the title was something like Sedimentary and Structural Analysis of um, Denali National Park, and it had two parts. It
Okay.
had a late Cretaceous basin there called the Cantwell Basin, which is essentially a late stage collisional or a post collisional basin. And then we were interested in what the basement of the Cantwell Basin is, and that got really interesting. There's an allochthonous terrain called the Farewell terrain, and part of it is juxtaposed against the North American margin in that location. And we didn't really know that it came over that far to the east or what those relationships were like. So that was more of a structural and large scale terrain sort of problem, and actually something that evolved in some pretty cool ways that I didn't know from the start as that went on.
Nice. This is fun. I'm just meeting you for the first time, and I can tell that you're going to be a great source of information. So let's finish your kind of narrative personally, and then let's go to a few of the maps that you have. They look like beautiful maps. So you wrap up that master's, the pandemic hits. What happens then? Do you keep going with Alaska somehow? And did you return then to Purdue as a doctoral student recently?
Yeah, what happened was I did defend kind of in the first year of the pandemic. And then I had accepted a job slightly before the pandemic hit with ExxonMobil. And so I went and I worked for ExxonMobil from early 2021 to the middle of 23. And then I came back to Purdue. And as I said, that's when I started working under both Ken and Mike Eddy.
Can I ask a personal question? Why did you
Sure.
return to school? Why wouldn't you just keep with that gig?
I was always interested in doing my PhD, and that opportunity came around, and I at the time actually decided, between the two after quite a lot of deliberation. And so I enjoyed the job, got a lot out of it, but I still felt like I wanted to pursue the PhD in an academic route. So it all worked out well. I would take the same route again.
Sweet. So the project that we are together on, terrible
Mhm.
grammar, is as far as I know, is related to the Talkeetna Arc. And even though we're just officially starting the project, you did have a full field season last summer, 2025, on the Talkeetna Arc work?
I've had two full field seasons actually
Okay, all
on that
right.
work. So I came back and had a year leading up to the first field season, which was in 2024. That
Okay.
was a big field season. We went and spent about 3.5 weeks on the Kodiak Archipelago, and then we also spent about 3 weeks on the Alaska Peninsula at a place called Pewali Bay, and that was a big start to the project. We really got a lot of work done that summer on different aspects of the record that we're looking at. And then in 2025, I went back to the Kodiak Archipelago to a Fognak Island for a few weeks, cleaned up a lot of the mapping, and that was sort of an iterative process that worked out very nicely having that second field season. And then the second half of this past summer, I spent some time back in the Alaska Range actually doing some new work on a collaborative project that stretches from the central Alaska Range down into California with some other folks.
Oh man, okay. All right. Well, you're the man. I can tell. You are the man, and this is great. Let's share your screen. Let's start with whatever you'd like to start with, and just kind of, I'm just going to be following along with the viewers, I think, trying to keep track of where we are, and let's just maybe just kind of go through some of what you just described, master's and PhD, and your work with Exxon with a couple of these maps. So however you want to do this, Brandon, but I think we've set the stage to really get the most out of these maps.
Yeah, I'll just, I guess, to give a little bit of geographic context for the different things we've been talking about, I'll
Good.
start with this terrain map. So this is one of the kind of typical terrain maps we see a lot working in the Northern Cordillera. And
Yes.
one thing I like about this, I chose to use this map from that was modified from previous maps and used by Cooper Frasulo in a paper from his master's because it also overprints the Jurassic Cretaceous sedimentary basins over
Mm-hmm.
top of the kind of bedrock and terrain geology. So when I was talking about my master's, I was working up in the Central Alaska Range, which would be up in here. I
Yeah.
mentioned the Fairwall terrain, which is this purple, and it was juxtaposed against part of the continental margin, which is basically this more pink or red. And
Mm-hmm.
then where I've been working now on the Talkeetna Arc project has been out on the Kodiak Archipelago on the southern coastline of Alaska and across the Shelikof Strait here on the Alaska Peninsula.
Hmm.
Um, so I think if you want to move into the Talkeetna Arc portion there, I can go to more of a Talkeetna Arc centric
Let's
map.
let's do that in a second, Brandon, but let's stick with this map. Do you mind a couple basic questions?
No.
Tell me about the peninsular terrain, which I have not seemed to run into at all. And the interview I did with Sarah Ruskey a month ago, she mentioned that peninsular ranges seems to be left off of many of these Baja BC discussions. I don't know the first thing about the peninsular terrain. Would you mind give us the most basic lesson on the peninsular?
Yeah, so we have the peninsular terrain in this light kind of lavender color here. And there
Thank
are
you.
some, I guess, geographic and terrain terms that can get confusing. We have the peninsular terrain here in Alaska, the peninsular ranges down by Baja, Mexico
Yeah, right,
region.
right.
So I would just start off by thinking about the peninsular terrain and what it relates to in Alaska. And
Mm-hmm.
what's the bigger picture there is that the peninsular terrain is one of three that comprise the Rangelia composite terrain or the insular superterrain. So on this map,
Mm-hmm.
we have the peninsular terrain in a slightly lighter purple, the Rangelia terrain, and also the Rangelia terrain is both in south central Alaska, and then there's a portion of it down here by Vancouver Island or on
Mm-hmm.
Vancouver Island.
Mm-hmm.
And then there's the Alexander terrain, which there's a little bit of in around the St. Elias in Alaska, and then in southeast Alaska and parts of BC and
And you
Yukon.
have and you have not dealt with the peninsular specifically with those different projects, or you have?
Prior to this, I was not working on the peninsular terrain. The reason to get in more of the peninsular terrain for this project is that
Yes.
the peninsular terrain has typically been defined as containing the Talkeetna Arc, which is a late Triassic to Jurassic arc. Um,
Aha.
that arc basically runs, at this point, I do think it'd be useful
Go.
to show
Let's
this one.
go. Good. You're in
Um,
charge. Love it.
so the peninsular terrain on this map is this blue here,
Yes.
Wrangellia's purple, and Alexander's pink. And then I'm
Hmm.
also showing the Chugach accretionary complex here. But the
Mm-hmm.
peninsular terrain, these stars are basically showing the distribution of magmatic rocks for the Talkeetna Arc. And you see most of them are on the peninsular terrain. They kind of butt up against the contact with the Wrangellia terrain in south central Alaska. And then also parts of, I know Sarah Ruskey talked about the relationship between the Talkeetna and what's called the Bonanza Arc down here, but they're very
Yeah.
much thought to be a formerly connected arc. And so the
Oh,
Bonanza component of that is built on the southern portion of the Wrangellia terrain.
okay. Uh, oh man. Okay. So I'm getting it. Can you stop your share for a second, Brandon?
Yeah, sure.
Okay, this is new and exciting for me. I never dreamt that the stuff that I have learned for much of Vancouver Island potentially has very similar narratives up with the Talkeetna Arc. Like I
Mhm.
just filmed a couple of PBS episodes on Vancouver Island, and we're looking at Carmoutzen basalt, and we're talking about the Sicker group that's below
Mhm.
that, and we're trying to place it geographically, and why do we have the flood basalts 225 million years ago, and so on. Would you mind just verbally reinforcing what I think I just heard? That are there, what are, just off the top of your head, or what are some similarities in storylines between Vancouver Island geology and the Talkeetna geology?
Yeah, there's a lot of key similarities. So I guess I'll start from oldest to youngest. How about that?
Love it.
So
Yeah.
the you mentioned the Sicker group and the Sicker arc in the basement of Vancouver Island geology. That's important because that was part of a Paleozoic arc system that essentially defines most of Wrangellia. And it was for a while kind of unclear if the peninsular terrain was part of that or if it existed, during that arc time. There's some data. One really pertinent study has shown that really part of the peninsular terrain basement probably also contains at least bits and pieces of that Paleozoic arc. So
Wow.
starting in the beginning, that's like really the first connection I would make thinking about
Oh,
Wrangellia Peninsular, that they probably had this Paleozoic history that extends a little bit into the peninsular terrain, at least in bits and pieces. And then you mentioned the Carmoutzen flood basalts on Vancouver Island. Those are a southern equivalent to the Nikolai flood basalts in south central Alaska. So they're basically time equivalent units, these flood basalts that define the Wrangellia terrain either in the north or the south. And yeah, they erupted between about 230 to 225 MA. And then
wow.
the arc, the Bonanza arc portion, so the portion on Vancouver Island, I believe starts around 210 MA. And what I think is really important about the Vancouver perspective on this Vancouver Island perspective is that there it's really clear that the arc was built on the basalts and on the Sicker group basement, which is really important. When we go up to Alaska, that's always been less clear because the peninsular terrain basement is almost entirely not exposed, just in a couple places. One of them being the place we went and worked in the Alaska Peninsula 2 years ago. And but also we have these flood basalts on Wrangellia in south central Alaska. And then it's been a little bit unclear, do those extend in other places? And we have similar age basalts that haven't been studied too much in the peninsular terrain. And that's been a big focus of our study because out on the Kodiak archipelago, we've been working on basalts that we didn't actually really know the age of. We knew they were probably late Triassic, but we didn't know the age of them. And we've been able to show that they're actually a little bit just slightly older than the blood basalts on Wrangellia as far as we know those age relationships. They're about
Hmm.
232 and a little bit older, but we're relating those basalts and the eruption of those to the initiation of the Talkeetna Arc. So now we have a relationship where we'd say that, the timing of these basalts and then the building of the arc on all of this basement is basically a more coherent story that we're starting to put together.
I mean, come on, that sounds pretty damn familiar to Vancouver Island with what I've heard so far of the Talkeetna Arc. Why do we even need the name peninsular terrain then?
Are you asking maybe why, if the arc kind of crosses terrain boundaries, why is it important to distinguish? Is that part of
I
that
guess
question?
I'm just hearing you were just describing the peninsular terrain or more specifically the Talkeetna Arc.
I was describing the peninsular terrain when it comes to the Kodiak Archipelago, and
Okay.
then I was describing the Rangelia terrain when it comes to the Karmutsin and Nikolai flood basalts and the
Yeah.
Bonanza portion. But I do think to your question there,
Yeah.
the connection, the fact that the arc spans different parts of both terrains does basically make you think, it makes me think that there are more similarities than differences. And
Yeah.
I think different people have been onto that in different ways through time.
Okay, well, that's really interesting. I mean, I get a little too excited sometimes, Brandon. We're just meeting. So, I mean, I get all spastic sometimes, especially when I can see similar stories that are geographically so separate with different names, different everything. And then you start realizing pretty close to the same story. And then, of course, then it goes to why are they so separate? And we don't need to go there with our discussion, but I didn't see that coming. And so I do want to do one more thing verbally, and then we'll go back to some images.
Mhm.
Mike and Ken's project and your project is looking at the initiation
Yeah.
of the Talkeetna Arc. What time frame are we talking about? And could we also be then talking about the initiation of subduction for the Vancouver Island stuff as well?
Yeah, I think they're very much related. So getting
Wow.
into the project, if you think about what were the existing constraints before we started doing this work, we basically had constraints like what are the oldest magmatic rocks? That's why we went to the Kodiak Archipelago, or it's one reason. The oldest magmatic rocks associated with the arc are out there, and that's part of what's called the Afognak batholith.
Hmm.
And some of the oldest ages were between about 212 and 217. So well, early to mid Norian, basically. What we went out there to do, our main hypothesis was that on the archipelago, the Afognak batholith intrudes this basaltic crust. So we can see that the oldest magmatic products intruded this crust. And as I mentioned before, there wasn't age control for the basalts out there. Those are called the lower Shuyak Formation. But our hypothesis was that, in many places on Earth, including, for example, the West Pacific arcs, where been a lot of IODP drilling and things like that to study crust that forms during subduction initiation, what happens is you get a slab sinking and rolling back. And in the upper plate there, you get extension and the eruption of basalts that basically through geochemistry, you can see it begins much like a mid-ocean ridge because you just have decompression melting and spreading in the upper plate. But then
Mm-hmm.
as the slab gets deep enough, you actually start to see fluids coming off of the slab and the geochemical signature of that. So we've been testing that hypothesis. I think that's very much turned out to be the case, that is how those basalts were created, and we've been able to date that sequence, and that was an age of 232 MA. And so that gives us the initiation story now back into the Carnian, which is an older, time frame to be talking about initiation of the Talkeetna Arc than in most other cases.
I love this. I got to say one more thing, and then I promise we're going to your slides. Like, I've been thinking about how to do this series, and I'm pretty sure that I want to start zoomed way out and take
Mhm.
terrains that are familiar to me from past programs that I've been doing here in the Pacific Northwest, down southern British Columbia and Washington. And here we are, without even me trying to work real hard to get us to like connect south to north. I mean, it's on a silver platter right now. And if I had read
Mhm.
your papers more carefully before we talked, I would have been a little bit more clued in. But I love this. I love drawing this in. Let's go to more of your figures. Uh, have you created these figures yourself, these maps and things?
Yeah, I can talk through that.
They're
Um,
beautiful. They're beautiful.
I'll move from this second slide to the third one. So this one
Sure.
is just
Uh,
one that
we
oh,
don't see
sorry.
your stuff
Yeah,
yet. Sorry.
sorry.
You're fine.
Here we go. Oh,
Good. Thank
all
you.
right. So I'll move from this slide here to the next one. This one
Yeah.
is one that, is using the state map compilation data for Alaska. gives
Good.
a good kind of first order look at the Talkeetna Arc in south central Alaska.
Hmm.
So the pink bodies here, these are all plutons associated with the arc. So
Okay.
out here we would be on the peninsular terrain. There on the previous terrain, simple terrain map I showed with the stars, I showed one set of stars that were showing a little bit older ages, and those would basically be all on this more outboard trend. So the oldest ages, like I mentioned, are on the Afognak batholith out on the Kodiak archipelago here, about
Ah,
say let's say 215 to I have some younger ones around 206 now from the
okay.
northeastern end. And then up in the Chugach Mountains, these plutons range from about 201 to 180 or so. And
Hmm.
then at about 180, the arc is shifted inboard. So on the Alaska Peninsula, these plutons, these range from about 180, some a little bit older, and then up into the Talkeetna Mountains, getting as young as about 153.
Hmm.
Uh, I'm also showing in here, this would over here be part of the Rangalia terrain. You can see these younger plutons come right up against this geology, but the darker purple is the Nikolai flood basalts that we were talking about earlier.
Yeah, right.
And
Wow.
then the blue is some of the Paleozoic arc related crust.
Well, first of all, can you help me with some, where are we here? Is Anchorage or Fairbanks or anything on this map or
Yeah,
Denali Park?
Anchorage is right here.
Okay, thank you.
Yep.
Yeah.
Then yeah.
Um, I don't want to push you too hard here, but is was the Nikolai connected to the Karmutsin at some point? Is that a common assumption for everyone, or are we into radical discussion already?
No, I don't think that's radical. The
Okay.
yeah, the connection between the northern portion of Rangalia and the southern portion of Rangalia in the late Triassic, I think is pretty well accepted that the flood basalts are related. So, a lot of the work that's been done on those basalts has considered them, one related piece of geology. I think
Hmm.
how they got separated is much more unknown and still
Mm-hmm.
a topic that different people are probably going to have some different models for, whether it's strike slip displacement, what time does that happen, things like that. But the general correlation I think it's pretty well accepted.
Very good. Whichever map you'd like to choose here, Brandon, can we look at your last two field seasons and just help us see where you were, all related to the Talkeetna project?
Yeah. So I'll show you the next map in a moment, which is going to be down here. That's basically including Shuyak Island, which is a small island at the northeastern tip of the Kodiak archipelago, and it's
Mm-hmm.
going to include part of Afognak Island here.
Okay.
This map is the only other, I think the only one I have in here that shows Wally Bay, but this is a location that we went to in 2024 in the
Hmm.
second half of our summer. The reason we went here is that this is one of the few locations where there is some pre-Triassic basement to the peninsular terrain exposed.
Hmm.
So we went out there because there's some Permian rocks. There was thought to be an unconformity, and we were mapping that unconformity and working to characterize it better because it's important to us from a Cordilleran geology perspective. It's important to understand what the basement is and the few places we can look at it for the peninsular terrain. But it's also important from a process perspective for the initiation story. We want to have some window into crust that existed before subduction initiation so we can look at
Hmm.
what were the processes that may have led to subduction initiation.
Mm-hmm. That makes sense to me, and I can't hold it. Is that stuff at Poale Bay similar to the Sicker basement in Vancouver Island?
Potentially. I don't think we can
Okay.
fully say yes. So the
Yeah.
oldest unit out there is a volcaniclastic conglomerate and it's barely exposed. So the problem still out there is we don't have a full, Paleozoic arc section to work with. And but I do think that between the presence of those rocks and then some
Mm-hmm.
of the other work that I mentioned earlier, kind of
Mm-hmm.
across from Anchorage, there's a modern volcano called Mount Redoubt, and there was a paper in 2012 by Bacon et al. That showed that there were Paleozoic gabbroxenoliths coming out and older zircons that basically they use that as like a window into the basement to
Hmm.
show that there's some more arc related basement there. And then if you were to go further east, then these blue units here, these are proper Rangalia Paleozoic arc basement that have been studied more and are more exposed.
Love it. Okay, so that was two field seasons ago. Do you want to share what you did just a few months ago, basically?
Yeah, so now I'll share this map here, which I've recently finished up putting this map together. This was the product of a couple seasons. Um,
Nice.
so basically, we've been doing a lot of mapping on the northwestern coastline, and a first order feature to look at here is the border ranges fault. So this fault, it's a good one to see because it runs all the way up through the Kenai Peninsula, up through the north side of the Chugach Mountains, and
Yes.
and it has generally been interpreted as marking the essentially the paleo subduction zone location for
Hmm.
the prior convergent margin, the
Hmm.
Mesozoic convergent margin in Alaska. And I'll note that pretty much to the east of that fault, this is still all previous mapping, and a lot of the early mapping was done in the 70s. And I think this was really excellent mapping work, pioneering work by a group out of mostly UC Santa Cruz. And
Mm-hmm.
so just wanted to note that because they spent like 5 or 6 or 7 summers or something like that mapping the whole archipelago coastline
Wow.
with an inflatable boat. And I've been working in this area, and I'm just always impressed by what they accomplish. So some of the goals of our mapping out here, what we've added to this is we have a few different packages to look at. So all the purple here, these are the oldest part of the section. These are the basalts I was talking about. Um,
Yes.
you'll see a few different shades of purple. So let me actually turn on the laser pointer just to help on the map.
Great.
So you have a darker purple here, a medium, and then a lighter purple you see out here and a little bit
Mm-hmm.
there. So what we've done is I've been mapping members of the basalts, and that was an iterative process essentially between doing the field mapping, going out the first season, and while mapping, we collected a bunch of samples for whole rock geochemistry to test that idea of these relating to subduction initiation. Went
Mm-hmm.
back, had about 20 or 25 samples analyzed in that first year and then came back with the knowledge of what we were seeing with that and used that to finish up the mapping. And that ended up being really powerful because it allowed me to go to places like right here or on a cross section from B to B prime here. It would be the contact between this lavender color and the blue and really know, yes, I expect to be right at the top of that section and look for very nuanced geochemical trends in that, but tie it to the mapping because the mapping was key there and needing to basically restore or understand these structures to accomplish all of that
Mm.
was one of the driving purposes of why we did all this mapping.
Are these different shades of purple part of the Nikolai group, or am I lost now?
So they're not called the Nikolai out here, and as far as we know from the age control that exists on the Nikolai, these would maybe be just slightly older. So
Okay.
the Nikolai is bracketed right now between about 230 and 225. I
Mm.
have an age from kind of the middle part of the section here of 232, and I'm
Mm-hmm.
working on another one that would be right at the top that would bracket the kind of last phase of eruptions. It's harder to find anything to date lower down because basically near the top of the basalt section we start to get some tuffs coming in, and that was what I was able to date. But lower
I see.
down, it's pretty tough. They're just they're basically up to green schist grade pillow basalts, and there are no tuffs in the lower part of the section. So we don't have any bracket of what was the very earliest set of eruptions, for example.
Doing great. My ears perked up when you said most agree that the location of today's border ranges fault was the original plate boundary, the trench, the place where an ocean plate was subducting. Why do
Yeah.
people think that?
There are a few different reasons on the archipelago. A really important geologic relationship is that just off this map down to the southwest, there are some blue schist facies rocks that Sarah Ruski worked on
Mm.
in her
Mm-hmm.
PhD. She had some early Jurassic metamorphic ages, and I think the oldest one uh, was 204. So right
Mm.
there around that Triassic Jurassic boundary.
Mm-hmm.
And so that marks we have subduction processes going on there. Um, you might wonder why is that structure right up against a magmatic record of the arc like the Afognak batholith, which is in pink here, and
Exactly.
that's been interpreted largely as the product of subduction erosion, so basically eroding the forearc away and
Mm.
moving that trench up to what would have been the early the early arc position. And I
Hmm.
like the Kodiak Archipelago for thinking about that relationship too, because it's a little bit less tectonically overprinted than up in the Chugach, where you're more in the orocline. And I think it's a little bit more difficult to think about that there. But here you can really see that key surface, as you're mentioning, had to come right up against that batholith.
Nice. This is really fun. I can zoom out and finish things out for a few minutes, but I think you maybe had another couple slides in your half dozen slides. Is there anything else you wanted to touch on visually before we start wrapping this one up, Brandon?
I guess I can, if you want to spend some more time on it, what I can show is basically why we think we have this initiation story here in the
Oh, good.
basalts.
Yeah. Yeah. Let's do
There's a
that.
there's a couple of plots. We did, as I said, a lot of whole rock geochemistry, and these are two plots that are important in that. On the left, this is basically looking at how would we classify these basalts? What kinds of tectonic environments did they form in? So all of the lower part of the section is shown on both plots as these yellow squares. And
Hmm.
before we even get to the right-hand plot, on this left-hand plot, we're using titanium and vanadium, which are both immobile trace elements. So even though these rocks have been metamorphosed to some extent, we can trust this data basically by using immobile trace elements. And we're seeing that the melts in the beginning were more like enriched mid-ocean ridge basalt and ocean island basalt compositions. And as we go up into the upper part of the section, so the green squares would be like the middle part of the section, and then these purple upside down triangles are the very top. We're seeing a
Mm.
transition into island arc tholite type composition. So this is basically a trend that we look at as a juvenile arc maturation type trend.
Hmm.
But to add to that, the other really key component is I mentioned earlier, we want to see this transition where as subduction is initiating, as what becomes the lower plate is sinking, we expect to have kind of mid-ocean ridge type compositions and decompression melting in the upper plate. But then as that slab gets deeper, we're going to start to see fluids coming off the slab through metamorphic dehydration reactions. And we're going to see a geochemical signature of that, or that's
Uh,
the test of this hypothesis. So this plot on the right takes us from the lower part of the section and shows a trend that we can attribute to the melting of that mantle. So as that slab is sinking, this is a position where we're going to get a high degree of melting. The mantle through decompression melting here is going to be melting a lot, even more so in many cases than at a mid-ocean ridge. And that's going to drive the trend from these yellow squares down to the green. And then up the y-axis, this is going to be controlled by that point when we see the fluids coming off of the slab. So
uh-huh.
one element like thorium is a good tracer of that. And that's basically showing us the key transition where now we're seeing a component coming off of the slab. And the last thing that I had sent you here is that this
Hmm.
is also where we can bring in the age control. So we want to understand something about how long does this take? What are the rates of these different stages? So far we have this key age here, which again, this is the one that gives us the first look at how old the formation is, these basalts. But it really happens at this sort of apex, at this dog leg between the trend that's tracking the mantle melting and then the enrichment from the slab or the onset of seeing a signature of the slab going down. And so we're able to timestamp that, and this is work from our lab here at Purdue using chemical abrasion TIMS, Mike's lab. And
Yes.
then, I'm working on another age right now that would be at the top of that. So then we could say, well, the duration of this early phase of the slab just beginning to be deep enough to start to sustain subduction and let loose these fluids, we could say something about how old that is essentially, and how long it took.
Okay, I got a million questions. Can you stop your share, Brandon? This has me. So this sounds like Mike Eddy country right now. Okay, we're talking about high
Yeah.
precise dates. We're talking about igneous geochemistry, and we've heard plenty from him over the years. Is this a new territory for you? If you were doing a structure and sedimentary type stuff with Ken Ridgway as a master's student, is this a major new set of ideas and techniques for you personally?
Yeah, most of what I've talked about here is pretty new. The project involves some things that are very new to me and some that are less new. There are sedimentary aspects of it. There's structural aspects that are more comfortable with where I've come from. But all of the geochemistry I've shown, That was a new direction. And then the geochronology, prior to my PhD, I'd done more with laser ablation type systems. And when I came back to Purdue, Mike's lab was up and running, and I started doing work with chemical abrasion TIMs. So that technique and learning that was also new.
So your advisor, Ken Ridgway, will be up in Alaska with us next June.
Mhm.
Is there a sedimentary component, or is Ken more far afield than I'm realizing?
Well, no, we're going to look at a lot of regional geology and the sedimentary
Okay.
components key to all of that. So I know, I think we're going to start in the Chugach accretionary complex near Anchorage, and so we're gonna jump back and forth between saying, maybe at one point we're going to be in a magmatic record of the arc, but we're also going to think about what was the sedimentary record in an accretionary complex at the same time, or in the Forearc Basin. We're going to look at the Matanuska Forearc Basin together. So it's going to be
Hmm.
a mix. Everything we do, I think, is highly integrated like that.
Well, that's a huge strength. I mean, I love that part, and so yeah, what I've seen so far from Ken and Mike, they're constantly doing that from different angles and different expertise. I think that's just so beautiful, and it's easy for me to come in and try to tell some stories with a camera and some microphones. I don't know if we're camping or not. Mike's a snorer. Brandon, are you a snorer?
No, but I spent a few days in a cabin with Mike. You're right.
He's nice about it, but I got Mike. We got to figure out where to place you tonight. We got to find Siberia for you in the campground here. Okay, well, good. Well, yeah, whatever we're going to do, I think viewers, we're going to be filming a number of videos during a week or so next June with Mike, Brandon, and Ken. At least it sounds like. Maybe one last comment before we sign off today, Brandon. I've been surprised as I've been collecting papers, kind of getting ready for this series, how much work has been done on the Talkeetna Arc. It seems like
Hmm.
this is not a new place to study. So can you be rather efficient, I guess, in a way to describe how this current grant is doing things with the Talkeetna Arc that were just not possible before?
Yeah, that's a great question. The Talkeetna Arc was studied in the most detail around the 2000s. So there was a large, at the time they were called Continental Dynamics NSF funded project, and it included looking at everything from the deep arc roots. So people were interested in what is the petrogenesis of melts from the mantle up. It is along with the Keough arc, it is considered one of the premier transcrustal magmatic systems to look at of an oceanic system in the world, and that's why it was studied so intensively. At the same time, people like Peter Clift and Amy Trout were working on the volcanic section, which is in the Talkeetna Mountains called the Talkeetna Formation. There are some key differences with what we're doing. The subduction initiation side of it is, I'm just looking at that record, moving back in time and figuring out what the record of it is completely new. I
Hmm.
wouldn't say that the techniques weren't around back then for the most part. I mean, high precision geochronology has improved over time, and we're certainly applying that. But really, I would say probably the reason that hasn't been done is that it's in areas where you work a coastline with a boat and things like that. It's just not
Yeah,
easy to do.
right.
Um, but also some key differences, like looking at the early part of the Talkeetna Arc. For example, the extrusive record and the Talkeetna Formation, it's both a combination of more proximal lava flows, volcanic clastics, part of a back arc record. And we're also spending time looking at like what does the volcanic clastic record say about the early evolution of the arc. So we have these other questions in there that are also new, like what can we say about how the compositional trends evolve in the very infancy of the arc and all of that. So that's why I think all of these aspects of the work we're doing now are just complementary to that, but really address an earlier stage.
Brandon, you're good. Come on, you're good.
Thank you.
You're a natural. I'm hoping to come back to you at some point and involve you a little bit more with what we're doing, and of course next summer as well. So please hold the line. I'll stop the recording. We can chat for a couple more minutes, but so pleased to meet you and thank you for your time here today.
Yeah, thank you.
All right.